All right, tonight we're going to look at slopes of parallel and perpendicular lines. This should be a pretty short video, and you probably are already kind of familiar with some of this information. So the first thing we're going to look at is the slopes of parallel lines. So if two lines are parallel, we know that they never intersect each other, meaning however they slant, that slant has to be exactly the same. So the slopes of parallel lines are equal. So slopes of parallel lines are equal. Okay, and then some more information that might be interesting for us to know is that two horizontals are always parallel. And likewise, two vertical are also parallel. Okay, so or two vertical, we'll add that in as well. So let's look at the following example. It says, is L parallel to M? That is the question we want to answer. So in order to solve this, we need to find the slope of each one. So let's start out with the slope of line L. Okay, so remember our slope is y2 minus y1 over x2 minus x1. So if we plug in the 2 points we have here, I would have for L -4 minus 3 over -1 minus -3, so plus 3. So that becomes -7 over 2, so -7/2. That can't be simplified. So now let's look at the slope of our line M. So I'm not going to write the formula again, we're just going to go ahead and plug it straight in. So we know that that would be -4 minus 5 over 2 minus -1, so plus 1. So that is -9 over 3, which simplifies to a -3. So are these lines parallel to one another? Well, no, they're not, because their slopes are not equal. Okay? So that's how we determine whether or not two lines are parallel. They have to have the same slope. If they don't have the same slope, it's not going to work. All right, let's look at this example now. What is the equation of a line parallel to y equals -x minus 7 and containing the point -5, 3? Well, first of all, let's look at the slope. The slope of our given line is -1. So the slope of a line that's parallel to that line will also be -1. So here we have the point -5, 3. If we want to write the equation and we know slope and we know a point, we can use point slope form, which is y minus y1 equals m times x minus x1. So plugging in the information we have, that would be y minus 3 equals -1 times x minus -5, so plus 5. Now what I'm going to have you do, this is point slope form. What I'm going to ask you to do tomorrow and in the future is to put it into slope intercept. That's just the one we're most familiar with. So if I wanted to do that, that would be y minus 3 equals -x minus 5. So y equals -x minus 2. So that would be our equation in slope intercept form. Okay, so it's not that hard to change it over to that. So that is parallel lines. Now let's look at perpendicular lines. So the slopes of perpendicular, well, they're definitely not going to be the same. So they're going to have to be different slopes. So we want to determine what would the slopes of these two lines have to be in order for that to be a right angle, for them to be perpendicular. Okay? And it actually turns out that the slopes of those lines have to multiply to -1. So the product of the slopes, or of the line slopes, must be -1 in order for those lines to be parallel. Okay? And then also, any horizontal and vertical line are always going to be perpendicular. Okay? So that's important to keep in mind too. For example, let's just look up here. I'll draw some little lines. Here's this line. That's a vertical. Here's a horizontal line. They are always, always, always going to intersect at a 90-degree angle. So they will always be perpendicular to one another. Okay? So let's look at what this means a little more for products to be -1. Okay, let's look at this example down here, and we're going to find an easier way that we can say that, or that we can look at that. So here we want to know if L is perpendicular to M in this equation. So we, again, need to find the slopes of each one. So let's start out with the slope of line L. So the slope of line L here, and I guess I should probably label these L and M, would be -4 minus 2 over 0 minus a -4, so +4. So that would be -6 over 4, which simplifies, don't forget to do that, to a -3 over 2. Okay, let's find the slope now of line M. So that would be -3 minus 3 over -5 minus 4. So that is a -6 over a -9, which simplifies to 2 over 3. So we want to know, are these two lines perpendicular? Well, if they're perpendicular, they have to multiply to a -1. So let's see what happens when we multiply those together. -3 over 2 times 2 over 3. So you get -6 over +6, which equals -1, which is what we needed. So yes, these lines are perpendicular to one another. Okay? So now I want you to notice something else about these two slopes. What are these two slopes? How are they related? Other than their product is -1, they're also just flipped and the sign changes. So they are negative reciprocals of one another. And that is another way to look at it, and it will help you solve these a lot faster. Okay, if you know that you just have to flip the slope and change the sign. So now let's look at this equation, or this problem. What is the equation of a line perpendicular to the line y equals 3x minus 5 containing the point -3, 7? So the slope of our given line is -3. So that means the slope of a line perpendicular to that one has to be, well, we need to flip it and change the sign. So if we do that, we flip it, we get 1 over -3, and change the sign, that becomes 1/3. Okay, so the slope of our perpendicular line just needs to be 1/3. All right, so now we have a point, so we can again use point slope form here. So that's y minus y1 equals our slope times x minus x1. So that would be y minus 7 equals 1/3 times x minus -3, so x plus 3. And again, I'm going to ask you to put this in slope-intercept form, so let's do that. That'd be y minus 7 equals 1/3 x. 1/3 times 3 is just plus 1. So that would be y equals 1/3 x plus 8. So the equation of our line in slope-intercept form would be y equals 1/3 x plus 8. All right, that's all for today, so come in tomorrow prepared to work.